In this video, we're going to figure out how to find the y-intercept from a table. So we know that the y-intercept is going to be the point where the line crosses the y-axis. We also know that every y-intercept can be written in the form 0, comma some number, in this case 0, comma b. And the reason for that is the y-intercept is located right in the center. And so any point that crosses the y-axis has to have an x value that's equal to 0. So when we're trying to find the y-intercept from a table, what we're really trying to do is figure out what y value matches when x equals 0. So keeping that in mind, let's go over some practice problems. So I want to figure out what the y value is when x equals 0. And to do that, I need to figure out what my slope patterns are. So starting off with my change in x, from 0 to 1, that's going to be a change of plus 1. From 1 to 2, that's also plus 1. And from 2 to 3, that's also plus 1. Now let's find my change in y. From 5 to 8, that's going to be a change of plus 3. And from 8 to 11 is also plus 3. So I know the slope for my table is going to be 3 over 1. And the nice thing about that is, even though I don't know what this point is, I know that my slope has to stay consistent throughout the table. So I know that if this is slope 3 over 1, this change has to also be plus 3. So now, in order to figure out what my y-intercept is, I need to ask the question, what number, if I add 3 more to it, is going to bring me up to 5? And the answer to that's going to be 2, because 2 plus 3 equals 5. So that my y-intercept is going to be 0, comma 2. All right, let's go over another example problem. So here, let's first find my change in x. From 0 to 3, the change in x is going to be plus 3. From 3 to 6 is also plus 3. And from 6 to 9 is also plus 3. Now let's find my change in y. So from 16 down to 12, I know that's going to be a change of minus 4. And from 12 to 8 is also going to be minus 4. So in order to keep the slope the same, I know it's going to be negative 4 over 3. This change also has to be negative 4 over 3. So now, in order to find my y-intercept, I need to ask the question, what number, if I take away 4 from it, is going to bring me down to 16? And the answer to that's going to be 20. Because I know that 20 minus 4 is going to equal 16. So my y-intercept is going to be 0, comma 20. Okay. Now that's our third example. Let's find my change in x. From 0 to 2, that's going to be a change of plus 2. From 2 to 4 is also plus 2. And from 4 to 6 is also plus 2. Now let's find my change in y. From negative 9 going down to negative 14, since I'm moving further down, that's going to be subtracting. And the difference between 9 and 14 is going to be minus 5. Right? And then from negative 14 to negative 19, that's also going to be minus 5. And to keep the slopes consistent, this also has to be minus 5. Now, another way of thinking about finding the y-intercept is going in the opposite direction. So I know that going from left to right, I'm subtracting 5 each time. But what if I want to go in the opposite direction? What if I drew the arrows going this way? If I'm going to the opposite direction, I need to ask myself, what's the opposite of subtracting 5? Well, the opposite of subtraction is going to be addition. So these arrows are going to be plus 5. And that kind of makes sense, right? Negative 19 plus 5 is negative 14. Negative 14 plus 5 is negative 9. So to find my y-intercept, negative 9 plus 5 is going to be negative 4. So my y-intercept is going to be 0, comma negative 4. Now let's finally do our last example. First, let me find my change in x. From 1 to 3, that's going to be a change of plus 2. From 3 to 5, that's also going to be a change of plus 2. Now let's find my change in y. From 4 to 10, that's going to be plus 6. And from 10 to 16 is also plus 6. To keep my slopes consistent, this also has to be plus 6. So what number plus 6 equals 4? My y-intercept has to be minus 2, right? Do you guys see a mistake I made finding the y-intercept? You guys might have noticed that I conveniently left out the change from 0 to 1. So I know that this jump here is only going to be a jump of plus 1. So what that means is this change in y down here can't possibly be plus 6. So what should be the change on the bottom be? Well, in order to figure that out, let's compare 1 and 2. I know that 1's only going to be half of 2, So I'm only making half a jump. So on the bottom should also be half a jump. So what should the change in y be on the bottom? Half of 6 is going to be plus 3. And so now, using that as my slope, I can figure out what my y-intercept is going to be. What number plus 3 is going to be equal to 4? 1 plus 3 equals 4. So my y-intercept is going to be 0, 1. And when I have a slope, which is only one jump, a slope where a change in x is just 1, this has a special name. This is called the unit rate. And this is still going to match up with my slope because I know that 6 over 2 can be reduced down to 3 over 1. So I'm still staying consistent throughout my table. So when I'm trying to find the y-intercept from a table, we have a couple of different strategies. We can figure out what number matches our pattern, we can make our pattern go in the opposite direction, or we can find the unit rate.